Okay, so behind the impeller now, as we move along to the back end here, this is something this is our design, but the mechanical seal in the back of the impeller consists of two different components, this type of seal. This is just what's called a single mechanical seal. You've got a spring assembly back here that just pushes off the back of the impeller. It then attaches to the back of that is a rotating face. There are two faces in a mechanical seal. The stationary seat, as you see with an O-ring here, okay, is pressed into the back of the cover plate. Okay, that is put in. These are very touchy. They're machined to light bands of flatness. Okay, when you put those two things together, it's very important to keep oil off of the faces, because as they run, that oil can heat up and flash and it will cause scarring. But as I rotate this, and Michael will show you, as I rotate this, the element here is the rotating face. This element here is the stationary seat. That's the thing, the weakest point of any pump is the sealing element. Okay, where those two faces come together, that's the only place that's keeping fluid from coming out of the environment. Okay, if you see a mechanical seal leaking, it's time to take action. Start to look, see if you've got parts in the store. If not, get them on order. But if it's dripping lightly, you'll see it coming out of the back end. This particular pump is fitted with dry run protection. So we have an additional lip seal back here where we have a reservoir of oil. If this pump were to be on a rental trailer or anything like that, you can't really run these pumps dry without burning up the seal. So what we do is we put a reservoir, not just us, but all of our competition as well, other manufacturers. There's a reservoir for oil to keep this sealing element cool. You can burn a mechanical seal up in about 45 seconds at 1200 RPM if there is no fluid present on either side. Okay, so be very careful not to run your pumps dry, because somebody's going to get mad at you if you did it, because it's a non-warranty failure and it can cost a lot of time and money to pull it apart. So in a standard pump flooded suction, this lip seal will not be here, and you would see fluid starting to drip out the back. Seals are actually designed to leak. Mechanical seals will, they need fluid across the faces to lubricate and cool. So what happens is, though, through heat of friction, it evaporates before it comes out the back side here. So they do actually leak very little bit, but they're designed to evaporate that fluid before it actually gets out to dripping on the floor or out to your drains. Okay, so that's the mechanical sealing element. What you're seeing here is typical of a design we have with a dished back plate here, which keeps solids away from here. Every mechanical seal, especially on the wastewater side, needs to be cooled, okay? Clean water pumps for potable water, you don't need as much flush there, but what we would do with this pump, if this was a standard stuffing box, which the design of a standard pump would have a narrow stuffing box like this, okay, and it's tapered. We have a large taper in our design. Other people will utilize what's called a taper bore stuffing box, and it closes the area down like that. Well, what can happen in that area? Solids can build up, okay? Where's the problem there? There's a lot of grit in what we pump, okay? So when those solids build up, if they're not flushed away from that area, okay, it's going to wear your seal faces. It can also pack in these springs and then cause them to compress, or to a point where it's going to tighten the seal faces too tight, okay, and then it's going to actually treat them like they're running dry. So what we would do to keep that protected is drill a port through here, and then you put an external flush line. So you put clean water comes in there, and that flushes that area out that you would see in the standard stuffing box arrangement. Okay, so that seal water flush is about 1 gallon per minute of every inch of shaft diameter. So if you've got a pretty big pump with a 4-inch shaft, you're using 4 gallons per minute of fluid to flush that. Okay, if you do not have a specific design pump that does not require a seal flush, you're not going to extend the life of the pump by bypassing it. You've got to put that seal flush in certain design pumps. So make sure you've got it on and make sure you've got it operational, or you're going to shorten the life of that. Okay? So that's a bit about the mechanical seals there. Okay? Behind the impeller, we have a rear cover plate, and that's where that stationary seat of that seal sits in. You can't really pull this pump apart and have the shaft sitting there and get that stationary seal out. So you would unbolt the back end here and take that rear cover off and put it on your bench. Okay? So when you have that rear cover and where the seat is, you just lightly tap the seal face out of that. You clean out the internal part of it. We have a video that's going to get more into seal replacement. So we'll get more in depth with that in a little bit in a video. We have a mechanic who's actually taking it apart. It's a lot safer to do that. But the rear cover does come off, okay? And with that, you now have just your bearing assembly here. Okay, one thing when we look at this, since we don't have this volute sitting in piping, how am I going to get this assembly out of that volute? Okay, there are jacking bolts on the rear cover here. Okay, and what you do is once you take all of your bolts out that holds the volute in place, you tighten those jacking bolts on opposite sides, and that will cause the pump to move away. You have to unbolt the feet of the bearing frame, of course, to get it to slide backward. And it's best to take the whole rotating assembly back to the shop to work on it, because you're going to have the proper tooling. Okay, the bearing frame itself, we've got a bracket in between the rear cover. That gives us space, to align everything. So when we get to the bearing frame itself, okay, it consists of lip seals on each end. The other end is not cut away. But these lip seals, what they are is just a little light metal cup for those of you who aren't used to pulling pumps apart. And it's got a rubber ring it's got a spring on it. It keeps pressure onto the shaft so you don't get contaminants in each end of the pump into the bearings. Okay, the bearings are the second weakest link in the pump. Okay, when they begin to wear, then you're going to start hearing rattling and vibration. Other things you want to look for in bearings is excessive heat. Okay, once in a while, even if you're just passing by the pump, put your hand here, put your hand here. If it feels like it's running hot, there's something causing that problem. Okay, and the problems that you want to look for is, do I have too high a pressure on my discharge gauge? That could be putting what we call radial loads on this impeller. Okay, and a radial load is up and down, where the actual loads are back and forth. If this impeller is getting too much back pressure on it, it's going to force it in a certain angle. It's going to stress your shaft. Okay, if you're starting to get vibration from that type of loading, you're most likely going to see it on this front bearing, because that's what's going to take that brunt of that first. Okay, and that's going to start generating heat in this area. Okay, so you want to be cautious of that. Watch your gauges. Make sure they're not exceeding what your design condition are. Okay, if you were designed for 50 pounds on the gauge and you're seeing 80, 90, you could be seeing excessive heat building up in this bearing, and you're going to see some in the back end. Okay, so something to be cautious of there. As I said, you unbolt the feet here. If this is a horizontal mounted pump, you do want to make sure you take your coupling out to leave room to slide the pump back and then turn it and move it out. Okay. The shaft assembly on this is a very heavy duty shafting and bearings on this. When you take your back cover of the pump off, if you need to do any work on your bearing assembly, you're going to disconnect the bracket in between. Okay, you're going to lightly loosen that at one point, and then you're going to have the rear bearing end cap here, if you want to come around this side. Okay, this bearing end cap on here, this just fits onto the top of these two bearings. Okay, so we would take 4 bolts out of here. Okay, take that end cap off, and that's going to have a lip seal in it. Okay, you take that aside, make sure you properly clean everything there. There is a keyway and a shaft here for where your coupling half would put that assembly together. You remove that so you can slide that cap off. Once this bearing cap is off, you're able to slide the whole assembly back. Okay, so your bearings in the back end and your front end bearings, and the shaft assembly will pull out and bring it back, and then you can remove your bearings for repair there, okay? Bearings are usually fit on, they are heated up and put on, so they are an interference fit as well, okay? Again, you're going to heat those up to a certain point, and they are going to drop onto the shaft. If you are rebuilding a pump, you want to make sure all your components are very clean, because anything can cause those to misalign. It's going to shorten the life of your bearings. What you've got here is, you'll see we have a single road ball bearing in the front end here. Those are mainly designed to help take up that stress on that shaft there. And then what we've got back here is a double bearing arrangement. Okay, and there are different arrangements for bearings. We utilize, and most pump manufacturers will utilize, a back-to-back arrangement. I put a little timer here so I didn't know. But this is a back-to-back arrangement. And what that means is, we position this where the balls are on the outer side on this bearing, and then the balls you'll be exposed on the outer side of the other. So we're taking the back of those bearings and bumping them together. Why do we do that? Because we can take greater stresses and greater forces. When we're talking about that impeller wanting to push forward, this arrangement is the strongest, this back-to-back arrangement. It's called a DB arrangement. It's called an O configuration also. So if you hear those terms, but this is the strongest arrangement to support that shaft, to keep that end play, as we call it, moving. I've seen big pumps where when you turn them on, that shaft will move a pretty good distance, because some pumps are really big. I mean, you could have vertical pumps that are, 800-900 horsepower. That's a lot of force, a lot of torque. So when that pump comes on, you can imagine a pump that big. Those bearings are about this big, but the back-to-back arrangement gives you the best capability of those, protecting those forces. Okay, as I said, these are heated to be put onto the shaft. To get them off, you need a bearing press. Okay, and you have to take the whole assembly there, and then you have to use a lot of force on a hydraulic press to pull those bearings up. Okay, you want to watch, make sure you, if you've got the ability to check shaft straightness while you've got it apart, take that and put it on the wheels and then check it out. You can put something for run out to check the end. Something else that we didn't talk about as of yet, underneath of the mechanical seal is a shaft sleeve. Okay, this is 4140 tool steel in the shaft. It's very good material. It's tool steel, very good tensile strength. There are higher strength materials for high stress situations, very high pressure situations, but commonly used in the market is 4140 tool steel. Now, when mechanical seals start to wear or you get vibration and such, what can happen is things can start to wiggle and jiggle on that shaft. Okay, you can imagine this shaft, not so big because this is a smaller pump, but imagine a big shaft and a bigger pump. What we like to do is protect that with a shaft sleeve. And what that sleeve does is slides over the end of the shaft where the mechanical seal is fit up. So where there is potential for movement and wear, you're putting grooves into that shaft sleeve, not into the shaft itself. Because that shaft sleeve, again, is a smaller machine piece. It's a sacrificial item. Okay, so when you do take that out, your shaft sleeve on this pump will probably be about 3-4 inches long. It's going to be equal to the diameter of the inside of the seal, and you will see if there is wear. There's going to be rings worn in there. There's going to be grooves, and we call that fretting. Okay, if you see that, do not replace that part. Or do not use that part as a replacement. Get a brand new part. Now you'll find in a lot of pumps like these, it's going to be a stainless steel shaft sleeve. It's a harder material than the sleeve itself. Make sure you get a good quality material. Okay, so that sleeve will fit back on. There's an O-ring inside of it that keeps fluid in the pump. It's a stationary fit O-ring, so it will just keep any liquid from creeping around the inside of the sleeve and coming out. So you have to be a little bit cautious with that. Make sure you don't cut the O-ring putting it on, but make sure you've got everything clean underneath. Okay, so basically, again, impeller, mechanical seal, shaft sleeve, bearing assembly. We do have assembly videos for bearing frames on YouTube if you care to look at them. It gives you more instruction on how to physically remove the bearings and put them back on, but for time's sake here and for safety's sake and not dropping heavy pieces, but that is how you get these out. When you do pull this apart, it just does pull out because they are loosely fit on the outer race here enough that you can pull the whole rotating assembly back out. If need be, you can use the convincer here on the end of the shaft to tap it to help work the bearing assembly back. The only thing before we put a video on to show you the seal replacement, talking about lubricating points. Okay, this particular pump being a cutaway, you know, we've taken away some of the points. Lubricating bearings. Okay, you're going to find that horizontal pumps like this are lubricated with oil. Okay, and it's very important to maintain a certain level. Okay, this here would have a sight gauge here. Others have a bullet sight glass. There's a line in the center of that. That line is there for a reason. If you exceed that line, you're going to over lubricate. Because what happens is you see these ball bearings roll around in here as this turns. Okay, if your fluid level is up too high, really we want it down at the lower end of that bearing race. If your fluid is up too high, those balls now start to slip in that fluid. They don't roll, they don't turn. So what happens when you take metal on metal and just slide it? You're going to oval them out. Okay, so do not over lubricate. It can be as damaging as not lubricating. But make sure you maintain those levels in your sight glasses to the right level. If you see it's down, get it back up there. You're going to see bearing temperature rise there too if you're under lubricated. It can rise when you're over lubricated as well. A vertically mounted pump, if you put it up right that way, you can imagine we would have oil laying here, so we grease lubricate. Okay, so when you lubricate your seals or your bearings that are vertically mounted pumps, okay, one sign is when you re-lubricate, you've got your lip seal there, you pump a little bit of grease inside there, and you're going to see the grease starting to weep out around the edge of that lip seal. That tells you you've got a little pressure buildup in there. Stop then. Don't over-pressurize and don't put too much in there. Again, going back to your operation and maintenance manual, I guess we can switch over. We want to switch back over so we can turn the video on this. On your operation and maintenance manuals, it will tell you the type of lubricant that you want to have in your pump. Okay, it's what the factory uses. We're going to disconnect that camera